Hello, this is the Erbauer 160 41PD 18 volt impact driver. A few years old now, but a good tool. However, it died on me the other day whilst driving 6-inch wood screws. Had to buy a new one to finish the job, and so with nothing to lose I thought I'd have a go at repairing it. Erbauer tools do not have a reputation for being serviceable, as they're aimed at the cheaper home improvement side of the market. However, I've found them very good value for money. Strangely, when the tool cooled off, it could decide to work again, but only for a short time. I thought that when it did work, I could feel heat in the handle. So I thought the problem was probably electronic rather than faulty hardware. Stripping it down and testing with a multimeter showed that there was nothing wrong with the switch or motor. Fitting another fully charged battery made no difference. There were no loose connections or lack of electrical continuity. The printed circuit board is seen here in the handle between the switch and battery, with a heat sink behind it. When I could get it going, I noticed that there was a hot area on the PCB. This was centered on one of the 2 pins securing the heat sink to the PCB, and became too hot to touch even after running the motor with no load for a short time. This shows the other side of the heatsink. The 2 screws which secure 2 MOSFETs to the PCB can be seen. The MOSFETs are sandwiched between the PCB and the heatsink. By now I was suspecting that the 2 MOSFETs could be overheating. Here you can see the 2 3-pin MOSFETs. This picture was taken after I'd desoldered them and the heatsink and unscrewed the MOSFETs and placed new thermal compound between them and the heat sink. When I first unscrewed them, I noticed that there was very little evidence of any residual thermal compound from the manufacturer. Also took the opportunity to resolder most components on the printed circuit board. I reassembled everything, patted myself on the back, what a clever chap, only to find that I seemed to have made things worse. Now it would only stutter for a very brief period into life and quickly die again. The LED in front of the switch now rapidly blinking before everything would go dead. Now not feeling so smug, I took everything to bits again and included the LED and its board and the PCB in a very close inspection and cleaning. There were some residual bits of solder on the PCB which I noticed and assumed could have been responsible. I noticed also that the voltage at the LED was surprisingly high at 20 volts. This, however, came down to 2.6 volts after further cleaning of the PCB and the LED PCB. I'm sorry that I don't have any videos showing all of this, but the 2 final videos clips show the impact driver now working in its various stages of reassembly. So far the driver has worked faultlessly. I've only, however, removed deep-seated screws with it. Hopefully the time spent repairing it will have cost me 1 tube of thermal paste, and it will be a useful secondary tool. If you've any comments, please leave them. I fully appreciate I'm only a beginner when it comes to electronics and may have been wide of the mark. Thanks for watching.